Welcome to 10 minutes CS. 5, 6, 7 permutations in string. We are given two strings S1 and S2 and we have to find if S2 contains a permutation, any permutation of S1. If that's the case, then we have to return true, else we have to return false. So in other words, return true if one of the permutation, that is any permutation of S1, is a substring of S2. Now what is a permutation? So let's say we have AB, so its permutation can be the AB itself or BA. So basically all the rearrangement of alphabets. So we are given a string S2 and we have to find the permutation of S1 in it. As we can see, the BA is present, that is a valid permutation of AB, so we are returning true here. The rearrangement of characters here signifies that the number of alphabets here should be same in any of the substring. If that's the case, then we return true. And it's exactly similar to finding the anagram of a string. So as we know that permutation here is same as anagram, so what we can do, we iterate over S2 for all the substrings and we can check if the frequency of the substring of all the alphabets from A to Z, as we are given here that it will consist only of lowercase English letters, is same as the frequency of A to Z in our S1 string. If any of the substring satisfies this condition, we can return true here. Else, if we have checked for all the substrings and we still haven't got the answer, then we will return false. Now let's look at the code for it. So firstly we have S1 frequency, where we are populating the frequency of all the alphabets of S1. Let's say we have AB, so as it only consists of lowercase English letters, so we will have a array of 0, 1, 2 till 26, where R0 will correspond to A, B, C, and 26th will be Z. And we can check for the index. So S1 dot character at I, let's say it is A, so A minus A will be 0, so we will increase the frequency of A to 1. Similarly, we'll increase the frequency of B to 1, and if we had BB, so in this case this would be updated to 2. Now we will iterate over S2. Let's say our S2 is E, I, A, B, D, O, 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 and we have created our frequency array here, which will be storing the frequency of characters in our substring. We have our boolean, which is found. We iterate from ith, our I will start from 0 till j is less than I plus n, where n is the length of our S1. So here the length is 2, so I plus n, that will be 2. So it's 0, 1, 2, 3 and so on. So less than 2, that means 2. That is, we are checking for same number of characters in S2 which are present in S1, so that we can check for the frequency, that is the substring length should be same, then only it will be a valid permutation. Also we have to check for out of bounds, and for all of them we increase the frequency of those characters, and then we check if our frequency is equal to the S1 frequency. If any of this case is not true, then we will make our found as false. But if any time our found is still true, that means all the frequencies of S1 is equal to the substring's frequency, then we return true. If we have exhausted all our substrings and we still haven't found as true, then we will return false. So the time complexity for this one will be, here it is O of, let's say it is n, so O of n, and here we are running our loop over our S2, that is m, and for each of them we are iterating n number of times, so m cross n, and here it's just O of 26. So the time complexity will be big O of n plus big O of m cross n plus 26. This is approximately equal to, if our m equals to n, so this will be approximately equal to n square. Can we reduce our time complexity even more? Let's look at this. Here what we are doing, we are actually checking for this window, and we are checking if the frequency is matching to our S1 frequency. Then we increase our ith pointer, and then we check for this window, and then we populate our frequency, and then again we check for this window, then again we populate our frequency again. So each time we are again reiterating from the start. But if we check in our substring frequency, if we are at our this window and we have to calculate the frequency, we have already calculated the frequency for this element in our previous frequency. So instead of recalculating, why not we just keep on shifting our window by deleting the frequency of the previously occurred with our, and add the frequency of the next one. So this is the hint for our sliding window approach. So what we will do here, we will have the frequency, but for that frequency we will not recalculate, we will just keep on increasing the jth pointer, and each time we do that we should decrease the frequency of our previous element which is out of window, while increasing the frequency of the newly added. Let's look at the code for this one. So first we have n is S1's length, m is S2's length. Now if any of the case where our S2's length is greater than our S1 length, that is there won't be any substring where we have same length permutation, so we have to return false for that. First we calculate the S1 frequency and our window frequency array, we initialize them, and here we are populating our S1 frequency same as above, and we add our first window's frequency to it. Now we check if our first window's frequency is equal to S1's frequency. We have used our R frequency equal function, which just checks for all the alphabets in our array and returns false and true. This is the same code as above. If that is the case, then we can just return true, as we have found one permutation which is satisfying the condition. Else we go ahead and check for our next window. So our I is currently at first index. Now we increase our ith pointer further, so it will come to here. Now we have to check for this window, right? So we reduced the frequency of this element, that will be I minus n, that is our I is 2 minus 2, which is 0, so that we can access this one. We reduced this frequency while in adding the frequency for our current element, and we check for if it's true, then we will return true, otherwise we'll return false. Now similarly we'll keep on increasing our I pointer, so our window will be keep on shifting towards the right. Now we'll check for this window, then we'll check for the next window, and for this window we will have the frequencies as equal, so we will be returning true here. Now what will be the time complexity for this approach? Here we are using O of n time, and here we are just iterating till m, so big O of m. So our time complexity will be big O of n plus m. For n equal to m, this will be equal to big O of n itself, as this will be 2 of big O of n. And our space complexity will be, this is 26 and this is also 26, so as both of them are constants, so our space complexity is constant in this case. Let's submit this code. It's exactly same as the one we saw there, and yeah, it indeed got accepted. Thank you for watching.